Whether as a result of a fight, bone cancer, or any other type of bone diseases, sometimes patients need to undergo facial reconstruction surgeries. Now, this oftentimes involves replacing and cutting a part of the fractured, degraded, or otherwise damaged bone and replacing it with a type of implant. Now, these implants are often titanium, off-the-shelf orthopedic ones, so they're not a perfect fit. But what if we were able to, thanks to 3D modeling and imaging, we were able to 3D print a type of implant that is specifically designed to fit one individual patient's face? That would be great. And in this episode, we're going to be delving into the world of PSIs, patient-specific implants. Don't miss it. Stay tuned. This is a PSI, a patient-specific implant, as opposed to off-the-shelf orthopedic implants that can be found in pharmacies even. The main difference is that orthopedic implants have standardized designs. Now, there's a lot of parts when you're thinking about orthopedic implants, and there's definitely a certain level of flexibility in picking and choosing the best fit based on the anatomy of the individual patient. But it is just that. It is the best fit. It is not a perfect fit. Now, that is perfectly fine in a lot of cases that when we're not talking about very complex facial reconstructive surgeries, like when we're talking about like spinal surgeries, certain joint replacements, certain bones and certain plates and screws and joint replacements and whatnot. In those cases, it's perfectly fine to use standardized orthopedic implants to use in surgeries. But there are certain cases, like in certain oncological cases, when there's when a bone is lost to cancer and the bone is in the face, so the surgery is very complex, very intensive, and a lot more accuracy in the parts is needed, and the tolerance is very low. Then we would need to customize the implant based on the anatomy of the individual patient. So there's certain preparations involved in the process of procuring a PSI for a surgery, whereas with an orthopedic implant, you can just buy off-the-shelf parts and use it in a surgery. And those preparations involve 3D modeling and imaging of perhaps the mouth, the jaw, and just overall the facial structure of the face to be able to virtualize and remodel a surgery in a software environment to kind of see what's the best approach to this particular surgical procedure. So we recreate that surgery in a 3D modeling environment to be able to find the best approach and also to find the exact fit that is going to be replacing that bone that perhaps may be lost to cancer, or there are some deformities as a result of, I don't know, impact or whatever the case may be. So as the bone is going to be cut and taken out of the face, the implant, which is very specifically molded and 3D printed with titanium, is going to be replacing it during the procedure. So this is some basic information about what we're going to be looking at in this episode. It's going to be about PSIs, but before we dive deeper into the manufacturing process, let's know a little bit more about the why and the how of PSIs compared to orthopedic off-the-shelf implants.
In our knowledge-based company, the primary service we provide is customer service for implants. This involves creating custom prosthetics tailored to individual patients, representing a new generation of services in the field of prosthetics. Unlike traditional methods and previous generations of services, these are designed, produced, and delivered based on the specific needs of the patient and the effects they are dealing with. The process begins with medical imaging, where we take the patient's images, typically CT scans, and input them into specialized software. We perform 3D reconstructions, and within the software environment, we are able to conduct virtual interpolation. Under the supervision of the surgeon, our design engineers implement various design methods and treatment plans on the patient's bone structure. visualize the results, and finalize the design after consulting with the surgeon. Once the design is finalized, the file prepared and exported from the software enters our production process. We utilize various technologies for manufacturing, including 3D printing and different surface finishing technologies, enabling us to complete a complex process involving more than 10 stages. The final product is then ready to be sent to the operating room where the custom-made piece is installed by surgical specialists.
Titanium implants have proven so far to be the best type of implant when an implant is necessary in facial reconstruction or cosmetic surgeries. This is due to their strength, biocompatibility, and ability to integrate with bone, or osseointegration. However, like any medical procedure, there can be potential complications or issues associated with titanium implants in the face, but they're not 100% free of risks or complications. The biggest inconvenience is that metal is more sensitive to temperature changes, particularly in cold weather, when you may feel that the implant has gotten way colder than the rest of your body temperature, and you would feel it. Over long periods, the implant may also move a bit and cause asymmetry, as rare as it may be. Or put a bit too much pressure on the bones around it, can cause deformation. As rare as both these cases may be, there must be a better way to go about these procedures. What if there was a material that could gradually degrade over time and be replaced by your actual bones? That means it can be metal, with all desirable and not so desirable properties that it brings. This is where we delve into the uncharted territory of bioimplants.
Now let's take a look at the lineup of PSIs that are offered to get an idea of just what they can do when it comes to facial reconstructive surgery. So we've got cranial implants, and all of these are models of actual patient skulls. We've got frontal, maxillary, orbital, mandibular, angular, and down here we've got chin and cheek implants, mesh augmentations, as well as superior stall implants. Now, like I said, all of these are models of actual patients' skulls, and this one in particular, I want to focus on it a little bit. So this particular implant allows the patient who previously only had this many teeth, making eating impossible. Now it allows the patient to have room for teeth implants, so they could actually eat. This is one of the more complex implants that are offered here, and of course all of these implants would have to be screwed in with either a steel or in most cases titanium screws. Now the traditional procedure when it comes to these facial reconstructive surgeries is the doctors would be using off-the-shelf orthopedic implants, mass-produced, and they would just have to pick the best fit, and during the surgery procedure they would have to keep aligning, fitting, and bending the parts to be able to get the best fit possible. But that's just it, the best fit possible. Whereas with these implants, you could just put the implant on the face, it would sit where it needs to be, and you could just screw it in, making the time that it takes for a facial reconstructive surgery to come down by a significant amount. Now, all of this is possible thanks to the 3D modeling of the skull and the facial structure that they can do in this facility, which also allows them to provide certain other services. Like, for example, we have these splints that are used in jaw realignment surgeries, which are replacing the traditional waxing method, which would allow the doctor to to find out where the jaws would actually need to fit exactly, to then be able to screw the implant in to fix the jaw in place. Whereas with these, you would just put these splints on the top and bottom row of teeth, and once they fit, this is where you need to screw in the implants. Another thing that this kind of imaging allows them to do is this very quality of life improvement clear aligners, teeth aligners, compared to regular orthodontics with the wires and the metal touching your teeth and your lip and your gums. This is a lot more convenient. Of course, the difference here is that each one of these models, each one of these clear aligners are going to be useful for like up to 2 weeks, because each one of these can only move the teeth by like 0.2 millimeters. So they need to be, your teeth need to be remodeled, virtualized again, and another one of these clear aligners needs to be essentially printed, so that you have to keep changing them for the 1 or 1.5 or 2 years that you need to put on a regular orthodontics. But this is a lot less aesthetically obstructive and a lot easier to just put on and take off, whereas with regular orthodontics you can't really take it off and it's annoying all the time. This is just annoying some of the times. Now with that said, let's actually take a closer look at the process of modeling and virtualization.
It all starts with medical-grade titanium powder, carefully selected with a precise grain size. Before printing, the powder undergoes preparation, ensuring an even and stable distribution. Once ready, the powder is loaded into the selective laser melting printer. This machine operates within 2 separate chambers, one for active printing and another for material replenishment. Using a high-powered laser, the printer selectively melts the titanium powder layer by layer. Each pass of the laser fuses particles together, forming a solid structure. As one layer is completed, the build platform lowers by 30 microns, though this can be adjusted for precision. Slowly, the implant takes shape, buried within the surrounding loose powder. Once printing is complete, the solidified component must be carefully extracted. Since the printed piece is encased in excess powder, it must be separated under controlled conditions. The surrounding powder is removed, revealing the implant within. At this stage, the implant is still fused to the build plate. A precision wire cutting process is used to detach it, ensuring clean separation. To relieve residual mechanical stresses from the printing process, the implant undergoes heat treatment in a vacuum furnace. This step enhances the material's structural integrity. Next comes surface treatment. Sandblasting, polishing, and acid etching improve biocompatibility, ensuring the implant is both durable and safe for the human body. The result: a custom, patient-specific titanium implant ready to restore function and improve lives, made possible through advanced additive manufacturing.
So far, we've only talked about these metal implants, which once they're planted, they're not going anywhere. But what if we were to replace the metal with a material that would actually degrade over time and be replaced by your actual bones?
The implants that were explained, the titanium implants that are now being manufactured as customized and PSI, patient-specific implants, are the latest products currently being used in global markets for patients and have resolved many issues. However, the technology of implants, in terms of materials, is related to second-generation biomaterials, and now third- and fourth-generation materials are also entering the market. These are materials that are biodegradable and, after a certain period, the body decomposes them, allowing natural tissue to replace the materials. The fourth generation even involves the use of living cells or tissues to create materials. Technically, and in terms of using 3D bioprinting technology, we have achieved self-sufficiency in our country, thanks to God, and we are benefiting from the services provided by domestic knowledge-based companies.
So the finish line appears to be in sight, which is the point where we're able to 3D print entire functioning organs using the patient's own tissue and cells, so that we know that this is going to be a successful transplant and the body is not going to reject it. Also, we no longer have to wait for an organ donor. But of course, the building block of us getting to getting to this point is going to be using this very biodegradable polymer-based implants that we talked about today. And with that said, we've come to the end of this episode of Iran Tech. Thank you guys for watching. I'll see you all next week.